Imagine buying like a $50 million skyscraper in Manhattan. Traditionally, that transaction requires armies of lawyers, massive title companies, escrow accounts, physical signatures, and just months of waiting while different banking ledgers slowly, reconcile with one another.
Oh, absolutely. It's a bureaucratic nightmare.
Right. Now, imagine executing that exact same transaction in 400 milliseconds on your phone while you're waiting in line for coffee.
Yeah.
When we talk about the massive global shift toward tokenizing real-world assets, what the industry calls RWAs, it is so easy to get mesmerized by that end result. We picture treasury bills or private credit or real estate magically living inside a digital wallet, and it captures the imagination.
Sure, it's the flashy part.
But today, in this deep dive, we are going straight down into the engine room. We're looking entirely past the shiny assets to figure out how that 400 millisecond transaction actually happens. Who is pouring the digital concrete? Who's building the specific systems that make tokenized finance a reality?
Because without that underlying infrastructure, a tokenized skyscraper is really just a neat concept sitting nowhere. The foundational framework here is essentially a logistics network. If these tokenized assets are the trains, the infrastructure layers we're examining today represent the rails.
Okay.
They are the tracks that allow digital assets to securely exist, to, move across borders, settle instantly, and be legally governed entirely on-chain. With these rails in place, you suddenly unlock a frictionless global industry.
Okay, let's unpack this. Because looking at the scope of what is being built right now, we are essentially watching a digital transcontinental railroad being constructed in real time. It's a massive, high-stakes global race to lay down the tracks that will dictate the plumbing of the next century of finance for you and everyone else.
Definitely.
And just like in the 1860s, there are competing companies, vastly different engineering philosophies, and massive fortunes on the line depending on whose tracks become the global standard.
If we connect this to the bigger picture, the scope of this construction project is staggering. Right. We're not just talking about one single piece of software here.
Right.
To make this work at an institutional level, you need base layer blockchains to act as the physical ground, tokenization platforms to serve as the onboarding stations, and entirely new, unseen systems for identity, legal compliance, and settlement to manage the actual logistics of moving the value.
Let's start with the ground itself, the bedrock.
Yeah, the base layers.
If I am a massive global bank, I simply cannot put my customers' highly sensitive regulated financial data onto a public network where anyone with an internet connection can see it. Why not just build one superchain? Isn't a multi-chain universe just going to create a fragmented, messy system for institutions?
You would think so, but the engineering around blockchains has evolved specifically to solve that problem. We are heading into a multi-chain universe because different financial assets require completely different operational physics.
How do you mean?
Well, it all comes back to a concept called the blockchain trilemma. It's this fundamental computer science rule that a network cannot be perfectly decentralized, maximally secure, and lightning fast, all at the exact same time. You're forced to make architectural trade-offs.
So instead of one giant superchain that handles everything, we're getting a highly fragmented map. Different tracks specifically engineered for different types of cargo.
Exactly.
When you look at the landscape, Ethereum seems to be the main hub.
Yeah.
It's heavily favored as the institutional default. Why do major financial players almost always start there?
Because Ethereum has the longest track record of security and something critically important called composability.
Composability.
Right. Think of composability as financial Legos. If you build a lending protocol on Ethereum and someone else builds a decentralized exchange, those two applications can seamlessly snap together because they share the same underlying mathematical logic.
Oh, wow.
Yeah. So you could theoretically borrow against a tokenized house and use the funds to buy a tokenized bond within a single instantaneous transaction.
It
is. It's highly secure, but because so many people use it, it can become severely congested and expensive.
Like the heavily guarded main freight terminal in a major city. Extremely safe, but incredibly slow during rush hour.
That's a great way to put it.
Which explains why a network like Polygon exists right alongside it, acting more like a high-speed commuter line to handle the overflow with much lower costs. But going back to that bank scenario, if they can't use a public hub like Ethereum because of regulatory concerns, where do they build?
That is where Avalanche comes in, specifically through an architectural feature called subnets. Avalanche allows a highly regulated institution to build its own private walled garden network that connects back to the main chain.
Wait, so it's a private network?
Exactly, a custom permission track. A bank can mandate that only users who have passed strict background checks can even see their subnet, let alone interact with it, while still utilizing the broader network's underlying consensus mechanism for security.
Okay, that makes perfect sense. You build a private, heavily regulated spur off the main railroad line. But what if the priority isn't privacy, but pure, unadulterated speed? If you're a high-frequency trading firm, milliseconds are the difference between profit and catastrophic loss.
Then you build on Solana. It is engineered entirely for high-volume, high-speed throughput. It is the bullet train of this ecosystem.
Right.
But speed isn't the only metric that institutions care about. When you are a clearinghouse moving billions of dollars across the globe, you care deeply about finality.
Finality, meaning the exact mathematical moment a transaction is considered permanently and legally irreversible.
Exactly. On many traditional blockchains, finality is probabilistic. You wait for a certain number of new blocks to be added on top of your transaction to be statistically sure that it won't be reversed or altered.
Okay.
A network like Algorand, however, uses a unique mathematical consensus mechanism where the second a block is written, it is scientifically impossible to fork or reverse.
No, it's instant.
Settlement is immediate and absolute. For institutions moving massive amounts of capital, that kind of architectural certainty is absolutely mandatory.
Okay, so the bedrock is heavily fragmented by design. We have specialized tracks for security, for privacy, for speed, and for finality. But tracks are completely useless without stations. How are massive institutions actually getting a physical skyscraper or a government bond onto an Avalanche subnet in the first place?
They use tokenization platforms. These are the specialized infrastructure builders who take a physical or traditional paper asset and legally convert it into a programmable digital token on the blockchain.
So they handle the logistics.
Right, they're handling the legal onboarding, the management of the investors, the dividend payouts, and the secondary trading mechanics.
Here's where it gets really interesting. Looking closely at what these platforms actually do day to day, they are essentially banks wearing digital trench coats. They are performing all the traditional roles of legacy finance, but they're using completely new technological physics to do it. Take a leading platform like Securitize, for example. They aren't just minting a random digital coin. They're ensuring that the digital token follows the exact same SEC regulations as a traditional paper stock certificate. How do they mechanically achieve that?
What's fascinating here is they do it by fundamentally rebuilding the financial stack from the ground up, rather than just slapping a blockchain wrapper over a legacy database.
Okay, give me an example.
Let's say you want to tokenize an apartment building. In the traditional world, you have to create a special purpose vehicle, an SPV. It's a mini legal corporation created in a place like Delaware, solely to hold that specific real estate asset.
Right, and investors buy paper shares of that SPV.
Exactly. And it requires expensive lawyers, manual contract updates, manual cap table management, and manual bank transfers to pay out rental dividends. It is a massive administrative headache.
And incredibly expensive to maintain.
Exactly. What a platform like Securitize or Centrifuge does is compress that entire legal company into a smart contract.
Wow.
The rules of the SPV, who's legally allowed to buy it, how the monthly rental dividends are distributed, what happens if a party defaults, are written directly into the code. The token itself becomes the bearer instrument, the settlement mechanism, and the automated compliance record, all rolled into a single piece of software.
That phrase, bearer instrument, is critical to understand here. If I hold a physical $100 bill in my hand, I legally own that $100. There's no central database at the Federal Reserve tracking my specific name to that specific serial number.
Right, possession is ownership.
Exactly. The physical possession is the ownership. These tokenization platforms are effectively creating digital bearer instruments for complex assets.
Precisely. And this is unlocking entirely new financial behaviors. Look at a platform like Ondo. They take the ultimate safe haven asset of the traditional financial system, the U.S. Treasury bill, and natively issue it on these digital rails. Suddenly, a decentralized application can hold U.S. Treasuries and automatically earn the government yield without ever needing to open a traditional brokerage account. They're building a massive automated bridge between the old world and the new.
Wait, on-chain monitoring?
Yeah.
Travel rules, identity verification. It sounds like the Wild West decentralized dream just met a wall of regulatory reality.
It's a profound culture clash, but it's the mandatory compromise for massive scale. The Wild West era of crypto was fine for early experimentation, but you simply cannot migrate trillions of dollars of global institutional capital onto infrastructure that is legally opaque or allows for anonymous money laundering.
Right, of course.
If these digital rails are going to carry global GDP, they must integrate legal adherence natively into the system itself. Trust and legal compliance are the ultimate prerequisites here.
Which explains the rise of the invisible machinery, the compliance and settlement layers that sit beneath the stations and tracks, completely out of sight from the average user. Let's look at how this actually functions. In traditional banking, there's something called the travel rule.
Yep, anti-money laundering.
Right. If you wire $10,000, the banks must legally share and record exactly who is sending it and who is receiving it. How do you enforce a travel rule on a decentralized blockchain?
You build specialized compliance rails. Companies like Notabene build software that allows financial institutions to securely exchange that mandated customer information alongside the blockchain transaction without broadcasting that sensitive data to the public ledger.
Okay, what about identity?
For identity, you have platforms like Civic or Fractal handling verification directly at the wallet level. Instead of a bank keeping a physical photocopy of your passport in a filing cabinet, your digital wallet receives a cryptographic proof that you've passed a legally compliant background check.
So it's automated.
Right. The smart contract can verify instantly that you are a sanctioned participant before it allows a tokenized asset to enter your wallet.
And what about the actual movement of the money? When that tokenized treasury bond pays out its yield, institutions don't want to be paid in volatile crypto assets. They need digital dollars.
That requires heavy-duty settlement rails. Circle, the company behind the USDC stablecoin, essentially acts as the settlement currency for this new economy. USDC is a digital dollar that moves at the speed of the blockchain, but retains the stable value of traditional fiat.
And holding those assets safely.
You need platforms like Fireblocks to provide military-grade digital vaults. A major commercial bank cannot afford a single point of failure when managing the private cryptographic keys for $1 billion real estate portfolio.
There is still one giant missing piece in this logistics network. We established earlier that the tracks are highly fragmented. We have Ethereum, Avalanche, Solana, all operating essentially in their own technical silos.
Yes.
If I have a tokenized real estate asset sitting on Polygon and I want to seamlessly use it as collateral for a cash loan on Avalanche, how does that actually work? You can't just drive a train off one track and onto another if they use entirely different technological physics.
This is where interoperability protocols come into play. Systems like Chainlink's CCIP or Layer 0. These are standardized, highly secure messaging systems that transmit data and value across different blockchains. To use the analogy, these protocols are the mechanical cranes that safely lift a freight car off the wide Ethereum tracks, verify that the cargo is legally secure, and seamlessly drop it onto the narrow Avalanche tracks.
Oh, that's a great image.
Without these interoperability layers, you don't have a functional global financial system. You just have a bunch of disconnected islands.
Okay, stepping back to look at the entire board, we have base layer chains violently competing to be the bedrock, tokenization platforms rebuilding themselves as the new digital banks, and interoperability networks functioning as the universal adapters. There is an incomprehensible amount of money and power pouring into this space. Who is going to end up owning the global monopoly on these new financial railroads?
That is the core geopolitical and corporate battle of our time. It fundamentally comes down to three competing factions who are all vying to dominate these RWA rails.
Okay, who are they?
First, you have the crypto-native builders. These are the software engineering teams who invented this architecture. They move incredibly fast, they understand the underlying cryptography intuitively, and they're building from a blank slate without any legacy technical debt holding them back.
Right. Then you have Faction 2, the traditional financial institutions, TradFi. The legacy banks, the massive clearinghouses, the Wall Street asset managers. They are incredibly slow, burdened by layers of bureaucracy and mainframe databases from the 1980s. But they wield unimaginable capital, regulatory influence, and political power.
Huge power, yeah. And finally, Faction 3 involves the hybrid players, the fintech startups, actively trying to build the translation bridges between the old TradFi world and the new decentralized world.
Right.
The critical dynamic to understand here is that the winner of this race won't necessarily be the faction with the fastest or most elegant code. The winner will be whoever earns the most institutional trust.
So what does this all mean for the listener? If TradFi is slow, but already has all the money and trust, isn't this game already rigged in their favor? A bank like JP Morgan or an asset manager like BlackRock already has all the money, all the global regulatory licenses, and decades of institutional trust. Why wouldn't they just wait for the crypto natives to finish debugging the technology, buy out the tracks, and run the monopoly?
This raises an important question, and it really comes down to the innovator's dilemma, playing out on a macroeconomic scale. Yes, traditional finance has the capital and the licenses, but migrating a massive global bank's infrastructure onto a blockchain is like trying to change the engines on a commercial airliner while it's flying over the ocean.
Wow, yeah.
It is incredibly dangerous and incredibly slow. The crypto natives have a massive architectural head start because they don't have to protect legacy revenue streams. The tension of this battle is whether traditional finance can learn to innovate and adapt fast enough, or if the crypto natives can build up institutional-grade trust fast enough.
Because trust in this specific space isn't just about a slick marketing campaign or a recognizable logo. It is built on functional, mathematically secure rails. A sovereign wealth fund is not going to move $1 billion over a network unless it works flawlessly every single time under extreme stress.
Exactly. And this is why those hybrid players have arguably the most difficult job of all. They have to sit in boardroom meetings and speak the highly nuanced language of legal compliance to global regulators, and then turn around and speak the language of cryptographic engineering to the developers. Bridging those two distinct cultures is monumentally difficult.
To help you, the listener, actually navigate this ongoing battle as it plays out in the financial headlines over the next few years, we want to give you a concrete framework. How do you evaluate whether a new tokenization project is the future of finance or just a sophisticated hype machine? If you're looking at a new tokenized fund or an emerging blockchain protocol, there are 5 key pressure points you need to test.
Right. The first pressure point is security. You have to ask if the chain and the underlying smart contracts have been battle-tested and professionally audited. Because in this environment, code is literally law. A single logic flaw in a smart contract can result in millions of dollars being drained by a hacker in seconds.
Very true.
The second point is compliance. Is identity verification natively integrated into the transfer rails themselves? If a protocol allows totally anonymous transfers of regulated assets, it is never going to win institutional adoption. It will be shut down.
The third pressure point is interoperability. Ask yourself, are the assets being tokenized trapped in a proprietary, closed-off silo, or can they move freely cross-chain using established industry standards?
Absolutely crucial.
Fourth is settlement. This goes right back to the concept of finality we discussed earlier. When a trade clears, is it mathematically irreversible? And is the custody solution holding the assets truly institutional grade?
And finally, the fifth point is the ecosystem. Are actual, real-world financial institutions actively building on this rail? Are developers continually writing code and maintaining the network? A state-of-the-art railroad track is completely useless if nobody's building towns or factories around the stations.
We really want to emphasize why understanding this infrastructure matters to you. You might be a seasoned investor actively looking to buy private credit tokens, or maybe you're just someone trying to understand the future mechanics of your own checking account and retirement fund.
Yeah, it affects everyone.
These invisible layers, the specialized blockchains, the tokenization platforms acting as digital banks, the settlement networks, they're going to dictate exactly how your money moves in the very near future. The underlying plumbing of global wealth is being fundamentally swapped out beneath our feet.
I want to leave you with one final lingering thought to mull over regarding all of this. We discussed how this fragmented multi-chain universe desperately requires interoperability and trust to function. But what happens to the assets that get tokenized on the tracks that ultimately lose this infrastructure war?
Oh, that's a dark thought.
Right.
Yeah.
If a particular blockchain fails to win institutional trust, or if its specific interoperability protocols become entirely obsolete, do the real-world assets living on it become stranded? Imagine legally owning a digital token that represents a piece of prime commercial real estate. But the specific digital tracks required to access its value or sell it have been completely abandoned by the broader financial system. Do those assets become permanently stranded on digital ghost trains?
A digital ghost train. The idea that you could own a highly valuable asset, but the technological rails required to access it just rust away in the digital wilderness. That is a haunting and incredibly real possibility to keep in mind. So the next time you hear a massive headline about a new real-world asset being tokenized, don't just stare at the shiny cargo. Look down. Look at the underlying tracks. Keep questioning the invisible infrastructure beneath the financial tools you use every day, because whoever drives the final golden spike on this digital transcontinental railroad is going to write the rules for the global economy. Thanks for joining us on this deep dive.
1, 2, 3, 4.
Cool.